Sometimes it just feels better to go in with a calculator. Just, a little security blanket. Okay. So I'm gonna I put the score when they got their caffeine. I put that into list 1, and when they didn't get their caffeine into list 2. What's it looking like so far? More depression with no caffeine. Yeah. This is only for caffeine addicts. If you're not a caffeine addict, it's probably not going to make it. Okay. So these are the scores for a person versus themselves, and we would like to see whether their depression improves or gets worse with no caffeine. So you usually want to find the difference between their score with the placebo and without the placebo. So if I'm going to find the difference, which way would you like to subtract? It doesn't matter. You just got to make a decision. No caffeine minus caffeine. So in list 3, I would put list 2 minus list 1. Okay, you can always do this the other direction too. You can do list 1 minus list 2. Just when you interpret, you'll need to interpret that you did it that way. Okay, let me read you the numbers that I got to see if you're kind of in the same ballpark. I got 11, 18, 1, 4, 6. Okay, all right, we're in good shape. All right, so let's start our 4-step procedure here. So we're going to estimate with what level of confidence would you like? 95? With 95% confidence. We're looking for a mean, so the mean I guess we're going to say the mean difference in depression score for caffeine addicts who take a depression test both with and without their caffeine. So we're going to look at the mean difference in their depression score. And we're going to go no caffeine minus caffeine score. Okay. So next I'm going to name my procedure. We're going to do a confidence interval for a population mean using a t-distribution, and we have a matched pairs sample. Okay. Now we're going to check conditions. Condition number 1. Do we have a simple random sample of caffeine addicts? No, we do not. We tend to, for experiments, we have volunteers. Yeah. So But what we have done with these volunteers is we have randomized treatments. So we don't have a simple random sample. We have and we've given them, the treatments have been control and caffeine. We have a controlled, randomized experiment, which is as good as a simple random sample of the population, because we're not going to get that. Okay. Next condition is about normality of the sampling distribution. Okay, so I check for the normality of the sampling distribution. Oh, well, now let me think of my sample size. What's my sample size? 11. And so that's less than 15, so I need to check for outliers. If I have any outliers, I'm not safe to proceed. So the best way to do this is to make yourself a little box plot. And my box plot, and you actually don't have to do a scale on these, but we probably should. My box plot's looking like this. I have no outliers. I'm okay to proceed with using the t-distribution. Yes. Yeah, if there's an outlier, you shouldn't be doing this test, not for such a small sample size. Okay? Number 3, independence. When we have an experiment, we don't say that we need our population 10 times bigger than the sample size, because we don't really have a sample. We need to make sure that the experiment was carried out so these subjects are independent of each other. So now subject number 1, their caffeine scores won't be dependent of their own caffeine scores because they're coming from the same person. But you probably don't want the subjects sitting out in the waiting room beforehand for an hour discussing what they think the experiment is about. You don't want the subjects, being able to say, well, I think I'm going to do this, just to mess up their experiment, which can happen. And you may not want to get all the subjects from the same age group, same family, same something, so that you'll kind of weed some of these these independent things out. So you need to check your design. Okay, so I think we've been okay with this caffeine test. This is why you go to a reputable researcher. They're, every university has them. So now I'm on to step 3. My confidence interval is still my mean plus or minus. Now I've got a critical t times the standard deviation of the sample divided by the sample size, by the square root of the sample size, thank you. And where should I be getting this x bar and this s? From list 3. Yes, we should. All right. So my x bar, give me an x bar, and s, I already know what n is. That's 11. And what are my degrees of freedom? 10. Okay. And minus 1. Okay, so what's my x bar? 7.36. What's my, it's going to be the Sx, not the sigma x. It means that you divided